Today we're going to be talking about systems of equations, and I'm going to show you just one method of how that we can go about solving those. There are multiple ways that they can be solved, but we're going to concentrate on the graphic method of solving them. So if you will look at my board, notice I have a system of equations set up already. One is 2x minus y equals 3. The other is x plus y equals 6. So in order to solve these graphically, what we're interested in to find the solution is seeing if these two equations intersect at some point. In order to be able to do that, we need to be able to graph them. So in order to be able to graph them, we're going to use a graphing calculator. And to do that, we have to solve each equation for y. So I'm going to take the first one, 2x minus y is equal to 3. And I'm going to solve that for y. So I start out by subtracting 2x from both sides. And I want to put it in slope-intercept form. And if you recall, slope-intercept form looks like this. Y equals mx plus b. So I subtract 2x from both sides. That gives me a negative y is equal to, if I put it in this form, I'm going to have negative 2x first plus 3. Then I want to get rid of the negative in front of the y. So I do that by dividing everything by a negative 1 on both sides. So that gives me y equals, I have a negative 2x divided by negative 1 gives me a positive 2x. And I have a positive 3 divided by negative 1, which gives me a negative 3. So now I have that in slope-intercept form where I can actually put it into my calculator and graph it. But before we do that, let's go ahead and solve the second equation. X plus y equals 6. It's a little easier. So we have x plus y equals 6. Remember, I want to go back to slope-intercept form. So I subtract x from both sides. So that gives me y equals a negative x plus 6. So now I have both those in slope-intercept form. So now I'm going to bring my graphing calculator and I'm going to graph each one of these. And what we're looking for to see if we have a solution. If we do, there will be a point of intersection. The first equation was y equals 2x minus 3. So I type that in, 2x subtract 3. And there's the graph of what that looks like. Then I want to do the second equation. So I have to get my function bar back up on my calculator. I do that by hitting Control G. My second equation was y equals negative x plus 6. If I enter that in, so I have a negative x plus 6 and press enter. Notice that the two equations do intersect. And that point of intersection is where my solution is. So if we look at our graph, and notice I've put the grid up on my calculator where I can see the point of intersection. That on the x-axis, if I count over 1, 2, 3, and then up 1, 2, 3, so that point of intersection is at 3, 3. So that would be the solution to my system of equations. The solution set would be 3, 3. Now, when I solve these, remember I mentioned this is one way to do this, or one method. There's also 3 options that I could possibly get when I graph these. So there's actually 3 possible outcomes or 3 possible solutions I can get. And to help me demonstrate that, I'm going to use a couple of lightsabers that I have to help you see the difference. And each lightsaber is going to represent a line. Now, the system I just graphed, we had a solution where the 2 lines intersected like this. So that's one possible solution. We may have another system where they don't intersect and they form parallel lines. And if you notice the lightsabers, they're parallel to each other. That would represent a system with no solution. And then finally, if I take this lightsaber and put it behind or on top of the first lightsaber, that represents another type of solution that we could have where they're both the same line. That is called infinite solutions. 3 options. One more time, let's review. We can have one solution, we can have no solutions, or we can have infinite solutions. Good day, my Patty 1 learners.